Welcome to our power quality improvement technique. We are going to have a 20 hours courses on it. So, this is the introductions class, and we shall discuss the scope of the power electronics and its definitions and its application and merits and demerits, and who own the responsibility and who are being blamed. Every issues, these are techno commercial aspect, we require to look after it to better understanding that paper. So, we have apart from the introduction class, so first we will again review the 2 pulse, that is, and the 6 pulse converter and their performance with the inductive and the capacitor loading. Thereafter, harmonic analysis of single phase and the 3 phase converter, THD, TDD and IEEE standard for the power quality. Thereafter, we shall discuss the different conventional method of power factor correction technique, controlled freewheeling operation, asymmetrical triggering, sequence triggering, thereafter sequence control, phase control converter, extinction angle control, PWM converter, single pulse, multi-pulse modulation technique. Thereafter, we shall go for high value converter, that is multi-pulse converter using delta zigzag polygon transformer and analysis and the harmonic calculations. Then power quality improvement technique using passive filter and their design. Thereafter, we shall switch it over to the shunt and series hybrid filters topologies and their control strategies, and thereafter it is again AC to DC conversion, and while we convert to the AC to DC, then power quality will be an issue. High quality single phase and the 3 phase power converter, that is active rectifier, control technique of buck boost control, power flow control, hysteresis carrier control and the space vector modulation. And considering these filters, that we require to search a suitable topology for it, and for this reason we will again talk about the multi-level inverter and the topologies of the control technique of the PWM technique. Then we shall see that snubber design, this is something will be new, and thus also will help to mitigate the power quality problem. So, this is we try to cover in 20 hours. We have me and my TAs has a very aspirational level to complete this syllabus, because this is our 40-hour syllabus. Mostly we have cut short few things, a 40-hour syllabus in IIT Roorkee. So, let us talk about the problem of power quality. So, we want the quality power. Thus, power quality refers to maintain a sinusoidal waveform of bus voltages at rated voltage and frequency. So, you should have a constant frequency and proper sinusoidal voltage and current with constant magnitude. Then you say that we are getting a pure good quality of power. The waveform of electric power at generation stage purely sinusoidal. Apart from there are diagnostics, and generally if we find that some broken rotor and all those issues are coming, then generally it has been replaced and repaired. So, mostly we can consider the generation stage are purely sinusoidal and free for any distortion. But in between, when the power reaches to me, but there are many sources of contamination, and thus many devices that distort the waveforms, and for this reason we get a contaminated power. This distortion may propagate all over the electric network, or it may be restricted or bypass or segregated. There are many options. If it propagates, then it causes hazards to the another person. So, this model can be like this. This is a classical model of the power system. You have a generation and you have another generation, because you may have a load that required to be feed from a different masses. So, transmission, this is a transmission network, there are two distribution network, there are two loads. Now, with the penetration of renewable energy, even loads become a distributed source of generation. So, so you can have a electric power network, and that can, this is considered to be a ring structures, and where all the customers are connected. If one of the customer polluting, then all will be affected. So, it is something like this. So, and now with the penetrations of the modern system, we have seen a commercialization aspect, and for this is in deregulation of the electric market. What does it mean by that? You generate power and you go to the power market and say that I am selling at 5 rupees. Someone generates power and sells at 4.3 rupees. Of course, I am a purchaser of the power, you have a of course, and then we will go for the, then of course, what happen, we will have a reverse bidding and we will take the least power, the consumer who produce a less power. That is what deregulation, this method started in the European Union because of the thermal power, because of the nuclear power plant. Power in France is quite cheap, and ultimately it sells power to all the countries. And Switzerland, because of the ecosystem, they do not want to put neither nuclear nor the thermal power plant, and their power was costly, and they were the net buyer of the power. So, in that way, so this was a regulated market started. Now, here also India, now we have a deregulations of the, we have a electric market, where we, well, let us say few days later, now when I am doing a lecture, it is in August, few days later we will have a Ganesh Chaturthi in Bombay. So, it will have a, or Mumbai, it will have a huge consumption of power. Just 1 month later, Calcutta will celebrate Durga Puja, and so it has to borrow huge amount of power. And what does this market does, it sells power. Like Calcutta will sell, Calcutta or the West Bengal Electricity Board will be selling power to the deregulation, and will have an account filled. And what will happen, once in West Bengal require power, they will get this power credited to their account. It is something like this. Apart from that, customer demand profile changes. That is also important issues, and this is a seasonal pattern, there is a and it is increasing at some percentage. So, you have to taken care of. And now, with the penetrations of the distributed generations, we can see that solar mainly, it is mostly it is fitted into the distribution system. We have a huge rooftop power system installation, which you consider to be the load. Now, it is also become a source of generation, and the cogeneration power plant, wind generation, these are also the part of our modern utility system. What is the power quality problem? For example, I am giving you one example. So, all of a sudden there is a spike, and this is called impulse, and all of a sudden you have a sag. So, this is also a power quality problem. Now, first of all, what kind of load we generally see? We have in our power system the resistive element, that is incandescent lighting. So, your 10 rupees electric bulb is nothing but a incandescent lighting. Thereafter, electric heater, and thereafter induction, and these are the resistive element. and mostly these does not dominate nowadays, but induction motor this entity consume huge amount of power and deteriorates power quality, because it also takes huge amount of the reactive power. Current limiting reactor, so you have seen that in a dual converter and all those entities, power electronics entity, you have a current limiting reactor, and that is the inductor element. Induction generations, for example windmills, damping reactor to attenuate harmonics, mostly in a power electronics converters, because solar inverter and other we have a PWM technique and we require to mitigate the harmonic, and damping reactors are used. Tuning reactor in harmonic filters, and thereafter it can have a capacitor element. Mostly this power is consumed in induction motor drive, and thus to mitigate this we have a solution, that is power factor correction capacitor bank, but that itself is nasty. We will discuss into the effect of the capacitor in a one chapter itself. They are to underground cable, because these are maybe in a different potential, and due to that the distance between the soil acts as a dielectric. So, ultimately shielding cable also comes into the pictures. This cable itself also behaves like a capacitive element. Insulated cable same way behaves like a capacitor element, and the capacitor used in harmonic filters. So, that is also can be used, that is intentional use, but these two are comes into the picture because of that its inherent property. So, the other linear loads such as electric motor drives, fans, water pumps, oil pumps, cranes, elevators, etc., not supplied through the power conversion devices like adjustable speed drive or variable frequency drive or any other rectification inversion of the current will incorporate magnetic core loss that depend on iron and the copper physical characteristics of those devices. So, these are constitutes our linear load, and now we can say that 30% of the power is generally consumed into the linear load, because we are moving more towards rectification inversion and the adjustable speed drive, and huge amount of power is being consumed there. Now, digital devices, though it takes small amount of power, but these are all quite nasty element. What happen, you have very high, it works on a clock pulses. The moment you have a very high clock pulses, so and C dV dt equal to I and L di dt equal to V, with that it interacts and it generates EMI EMC problem. So, these are the another issues here that has to localized here. So, all those digital equipments are essentially required to convert AC to DC, thereafter there will be a chop DC. Once you convert AC to DC, since it is a nonlinear conversion, you have problem with the harmonic, and you thereafter make a pulsation kind of entities, and that leads to the more EMI EMC noise. And this is an example of the nonlinear load. This is adjustable speed drive. So, it may have a V by F control. Once you control V by F, your flux remains constant. So, thus your torque will be proportional to the current. If you keep the current constant, then your torque will constant. So, you can get a smooth variable speed in a V by F control, and this is an example of the electronic plus lighting. So, this will also nonlinear devices, once arc comes and goes, so once arc comes there is a peaky notch and like this, and thereafter there won't be, thereafter very small amount of current will flow, all of a sudden there will be a notch. This will be the current profile for this. And similarly arc welder, so once it is get short circuited, so then only it will be, arc will be there, and once arc is there you are trying to use the arc. So, this will have a this kind of peaky nature, all of a sudden there will be a sudden jumps in the current. So, these are the few application where we use frequently this nonlinear loads and thus deteriorates the power quality. So, I am giving you an example of our data. So, look, this is an example of the power quality problem. So, this is a sag example, all of a sudden sags comes, it may be that a branch of the T it is touching. So, it is the scale is in lower range anyway. So, scale it is touching the T's and comes down, but it is for the high voltage that will be in a level of the kVA, but it may be so that some kind of voltage sag has occurred, and so we will define what is sag and all in a subsequent classes. So, this is the example of the sag, and this is also a problem. So, classification of the power quality areas may be made according to the source of problems such as converter. Once you convert AC to DC and you let us and you have a let us say a diode with rectifier and your inductor is quite high, then your load current is continuous, thus your source current will be a square wave. So, you can do the Fourier series analysis and find it out what are the harmonic content. So, this is the case, and depending on the capacitor, depending on this RL, RC and different combinations. So, input current profile will be distorted. Magnetic circuit nonlinearity. Transformer works on the principle of the demagnetizing of the flux. If current enters this point, then current will leave to this point. If load is very high, then there is a, then in the BH curve it will be close to the saturation. Once it is close to the saturation, then because this region is linear region of the BH curve and thereafter it goes to the saturation. So, if it is in a unloaded, so then current you will find it little peaky, because so demagnetization does not occurs, and this is the problem of the magnetic transformers as transformer goes into the saturation mode. Thereafter arc furnace by wave shape of the signals such as harmonics. Arc furnace also will have a same problem. Flicker, we shall define all those entities by the frequency spectrum, radio frequency interference. So, it is above the audio frequency, this will cause many problems in the communication network. Now, source of power quality problem, which it may be more, that the wave shape phenomena associated with the power quality may be characterized into two broad categories. One is synchronous, that is a 50 hertz problem and its harmonics, and non-synchronous phenomena like lighting strikes and all those issues. So, once you know that it is a synchronous phenomena, then you know that how to mitigate it properly. You calculate and mitigate the harmonics maybe which is required to be injected. Like you know that in a square wave consisting of it is this kind of waveform, you can do the spectrum analysis and this is repeated. So, it is a synchronous problem, and once it is a synchronous problem you can apply a particular correction technique and get rectified, that is a you can do it in a shunt active power filter. But if let us say thunder strikes, lightning strikes, then it is asynchronous phenomena. It does never know that when it will strike. So, for this reason, eliminating the synchronous phenomena is easier, and thus we can say the synchronous phenomena refer to those in synchronism with AC waveform at power frequency. So, now let us come to the cause of the power quality deterioration. So, few are the natural causes, it is not human inflicted. For example, faults of a line, LG fault, so voltage sag will occur, unbalance will occur. Lightning strikes on the transmission line or the distribution feeder and it propagates since it is a surge. Falling of trees and the branches on the distribution feeder during the stormy condition and equipment failure of the relay or any other entities. So, that leads to the natural cause. And thereafter, it may be due to the load or the transmission line feeder operation, transformer energization. So, once it's energization of the transformer, you excite or the transformer. So, then what happen? It will have a high inrush current and the voltage will sag, and this is the problem of a transformer energization. So, that also cause a sag in the voltage. Capacitor or the feeder switching, capacitor will charge very fast and thus it will cause a dip in a voltage initially, and thereafter is undamped circuit it continued to oscillate. And thereafter power electronics load, and power electronics load mostly we have a voltage source and these loads are generally constant impedance load and these can be constant power load. So, if the voltage is low it will take more current, then thus it has a more problem from the stability point of view, it will take you to the more unstable region, that is another issue. So, it can be uninterrupted power supply, we generally very frequently use with our desktop. So, thereafter we can have ASD, that is called adjustable speed drive, and different type of AC to DC converter, etc. Thereafter we can have a arc furnace and induction heating system. So, that also cause a problem of the waveform. Switching off and switching on the large load, that may create disturbance to the power system network. So, this is due to the transmission line or the feeder operation. 4 major reasons for the concern, that is the newer generation load equipments are very sensitive to the power quality. If it is not fitted with a good quality power, its life will deteriorate. Why? Very simple example, if you are feeding a square wave instead of the sine wave, your sine wave you have, if you differentiate it, you get cos wave. So, rate of change of this rate of change of voltage is quite low, and since in this kind of nature it will break down the insulations of the winding, thus it degrades and deteriorates its performance, its lifespan also decrease, and ultimately you put into the cost, that also comes, instead of the 15 year it will last 6 years, and also its performance also will be less. And thereafter increasing harmonic level on the power system. If you have a more harmonic, it will create more distortion to the system. And for this reason, THD is a measurement of the harmonic, total harmonic distortion. Total harmonic distortion required to be low as prescribed by the different standard that I have taken a separate class on the standard. So, there I will discuss in detail. End users have an increased awareness of the power quality issues, because since they are taking money and they are not doing any charity, I have a right to get a good quality power to ensure that my equipments last long. So, we can also become more aware, so that quality power to be given. Many entities are now interconnected in a network. That means that someone is installing the solar rooftop system and they are giving you the energy guarantee to the system, that apart from the utility grid. So, many entities are now interconnected in the network. Integrated process means that failure of any component has much more important and consequences. So, for example, it happens to our institute that if few days ago there was a power cut because of the feeder was removed, feeder was bad, but solar was generating power and ultimately we failed to evacuate that power because of lack of power supply. So, and for this reason we require to stop this inverters, solar inverters. So, for this reason we have a different entities, they are linked together. So, it is not that the consumers does not get power, but also solar company fail to sell their power and they sell that, look, I have a energy commitment of this much, I failed to deliver because of you, and they can take a legal action. So, this is quite complex for this reason nowadays. The increased concern about the quality of the electric power is to be continued to push for increasing productivity for all the utility concern, because if you have a bad quality power, your industrial production will go down, ultimately you will hamper your production cost and your labor cost will increase. So, ultimately there is a cascading effect to it. Now, this utility customer always want increased productivity, and definitely the manufacturer wants faster, more productive, more efficient machinery. And utilities also has the philosophy that encourage this effort, because it helps this customer become more profitable. In that way, they can also sell the power at a good tariff. So, now let us come to the definition of the power quality. Different books write different definitions. Whole power engineering, whole of the power engineering, in one way or other it is related to the power quality. There is also no universal agreement for the definition of the power quality. A power quality may be defined as power quality as reliability and like this 99.98% reliable. So, why not 99.99? So, these are the tricky questions, and hopefully you will understand after finishing of the course why these definitions are being formed based on different standard and different requirement. And also from the manufacturer's point of view, manufacturers of the load equipment may define the power quality as those characteristics of the power supply that enable the equipment to work properly. These characteristics can vary different for different criteria. Power quality is ultimately a consumer driven issue. I may require a particular power quality for a particular machines, and thus we define power quality as any power problem manifested in voltage, current or frequency deviation that results in failure or misoperation of the customer equipments. So, then we will say that we have a power quality problem. So, this is something that we are, this is the power quality definition and how power flows and how power get contaminated. We have taken an idle power example, and there is a idle power dam. Thereafter, it can be 50 or 60 hertz, and from the transformer it comes, and the transmission distribution system, the transmission and the distribution system power quality, nominal voltage plus 5% plus minus is available to you. Thereafter, transformer, regulators, circuit breakers, that you got a capacitor bank, you got a load switch, you got a again regulator, there your distribution meter, thereafter you got a air in your house, you got a television, you got a water heater, you got a meter to bill it out your bill. So, this is a way from here you get the power to here, and in between generally here power is satisfactorily generated, all are sinusoidal, but in between some way it been corrupted. And what happen, if you give, if by some problem if you get a corrupted power, then your equipment will not last long or malfunction. So, thus we require to ensure that from this point to this point power quality is been maintained, but mostly though it is restricted to the distribution system. So, transmission system does not have much problem on the power quality apart from the voltage sag. Thank you for your attention. I will continue my discussion in my next class.